Physics, first PUC, the chapter number 4. So in this chapter, the total marks covered 13 marks and it is very important for JEE, NEET as well as CET. The topics to be covered from this chapter is Aristotle fallacy, Newton's first law of motion, momentum, Newton's second law of motion. Based on Newton's second law of motion, force is equal to mass into acceleration, Newton's third law of motion, some examples of third law of motion. Based on third law of motion, horse and cart problem, and the next topic is law of conservation of linear momentum. It's very important for your exam. And next topic is equilibrium of a particle, common forces in mechanism. The last topic from this chapter is friction and circular motion. So our first topic is Aristotle fallacy. What is the statement of Aristotle fallacy? The statement of Aristotle fallacy is an external force is required to keep a body in motion. This is a statement of Aristotle fallacy. So it was proved wrong by Galileo and Isaac Newton. So this is Aristotle fallacy, has done some experiment, but it is wrong. It is proved by Newton's and Galileo. So you can just observe this diagram. This is inclined plane. The ball is released from the rest on one plane. The ball is released from the rest on one plane, rolls down, and again it is climbs up the other in the absence of friction. You can just observe this once again. The ball is released from the rest on one plane and it is rolls down and climbs up to the other. In the absence of friction also, it is climbs up on the other inclined plane because of friction. So this is proved by Newton's and Galileo. What is the Aristotle fallacy? Suppose if I am going to take one example, if I want to pull the bench, or any object, I require force. Suppose if I want to move from here to there, I need the external effort to move from one place to other place. But what Aristotle said, an external force is required to keep the body in motion. Actually that is wrong. It was proved by Galileo and Newton by this experiment. We need external effort. Just if I want to pull this ball, when it is rolls down, I do not need the external force to climb up the ball to the another inclined plane. So this is proved by Newton's as well as Galileo. Just see this example, it is very important. The ball released from the height, from rest. You can just see this, the ball is released from rest. In case 1, it reaches the same height on the other side. You can just see this second case. The ball reaches the same height on the other side. And the third case you can just see, which is a limiting case, the ball rolls down and continues to move in the horizontal plane. If you release this ball compared to this and this case, without friction, the ball A and the ball B, it reaches the same height without friction. But in the third case, if you rolls down, it continues to move in the horizontal way through infinite distance in the absence of friction. This is most important example proved by the Galileo and Newton. In the last slide, we observed 3 cases. Balls rolls down and it moves at the same height in the absence of friction. As well as in the second case, it also moves down and it reaches the same height. And also in the third case, it moves in the horizontal plane infinite distance. You can just say this. We get to know what is the Galileo's statement. So Galileo's statement is, Galileo arrived at the new insight that a body is at state of rest or in uniform motion compelled by an external force. Suppose a body is at rest or the body is in uniform motion unless compelled by an external force. If you are not applying a force on that particular body, if the body is at rest, if you are not applying the force, the body is at rest only. If you are not applying a force on the body is in uniform motion until and unless the body is in uniform motion. This statement given by Galileo. And the next is inertia. What is the meaning of inertia? If the net external force is 0, a body continues to be at rest or the body continues to be in uniform motion. So this is the statement of Galileo, and he has proved one of the most important word, that is inertia. So what is the meaning of inertia? Inertia means resistance to change. Inertia means resistance to change. What is the meaning of inertia? Resistance to change means, suppose if I want to take this cardboard, suppose if the body is at rest until and unless, if I want to apply force on this, it will be at rest. Suppose if I want to move this, from here to there, it is in uniform motion, I need to apply a force on this. Means inertia means resistance to change. Resistance to change means we need the force, then only the body will move or it is at rest. So the next is Galileo's law of inertia. This is the last statement given by the Galileo's law of inertia. A body does not change its state of rest or in uniform motion unless an external force compels to change its rest. The next topic from this chapter is Newton's first law of motion. What is the statement of Newton's first law? Everybody continues to be at rest or uniform motion unless compelled by an external force. This is the statement of Newton's first law. You can just see this example. The block is at rest. The normal reaction force must be equal and opposite to its weight W. So what is this W weight? Due to force of gravity, it is exerted on the table. Due to normal reaction force, the block is exerted by the table. Suppose, what is the example, what is the statement of Newton's first law? For this example, the block is exerted on the table by the normal reaction force as well as acceleration due to gravity. Suppose if I want to apply a force on this block, it just starts move from here to there. If I want to apply the force on this block, it will not go anywhere. That means everybody continues to be at rest or in uniform motion unless compelled by an external force due to normal reaction force as well as acceleration due to gravity. So this is the statement of Newton's first law. You can easily understand by seeing this example for Newton's first law of motion. You can just see this example. The block remains at rest. The block remains at rest. If I need to apply the force from here, then only it starts moving from here to here. So means until and unless it is acted upon by an external force. This is one of the example. And the second example is, see this example, the ball continues to be in uniform motion from here to here. The ball continues to be in uniform motion unless and until it is acted upon by an external force. Suppose if the ball is coming from here to here, it is in uniform motion. Suppose if I want to stop the ball, I just want to apply the force like this. Then only the ball will stop. This is the second example of Newton's first law of motion. And you can just see the third example. The car is moving in a straight road or a highway road. The car continues to be in uniform motion in the absence of external force. You can just see this one more time. The car continues to be in uniform motion in the absence of an external force. This is a very good example to make you to understand Newton's first law of motion. The next topic is inertia. There are two types of inertia. One is inertia of rest. The examples of inertia of rest is, suppose a passenger in a bus jerks backward when the bus starts suddenly because of the passenger tends to be in inertia of rest, whereas the bus is moved away forcefully. The next example is, when a bed sheet is flicked away suddenly, dust particles falls away as they tend to be in inertia of rest. The next example, when a branch of tree carrying a mango is suddenly flicked, mango falls off due to inertia of rest. These are the examples of inertia of rest. The next type is inertia of motion. These are the examples of inertia of motion. First example is, a passenger in a bus jerks forward when the bus stops suddenly because the passenger tends to be in motion, whereas the bus is stopped forcefully. Next example is, an athlete after reaching the finishing point can not stop suddenly, or if he stops suddenly then he falls toppling head down. A rotating fan continues to do so for some more time even after the current is switched off. Next is, a car takes some time and moves through some more distance before coming to rest even after the application of brakes.